Good morning, everyone. Today we'll start with the chapter Solutions. Class 12. In this video, we'll discuss introduction of the chapter and some concentration terms, and we'll also discuss practice some questions regarding that. Okay. So, what are solutions? Solutions are the homogeneous mixture of two or more components. That means in a solution there is a solute. Okay, there is a solute plus solvent. Okay, if there are two components of a solution, or we can say it includes one solute and one solvent, then that kind of solution forms a solution. Then that kind of solution is called a binary solution. So basically it is a homogeneous mixture. If the two components, that is the solute and solvent, could be both of them could be solid, both of them could be liquid, or both of them could be gaseous. So and also the combination of these. So there are different kind of mixtures. Homogeneous mixture, the criteria for to be defined as a solution is that it should be homogeneous. Okay. So coming to the components of a solution, if it contains two components, then it is called as a binary solution. So binary solution is defined as a solution that contains two components. One is solvent and another one is solute. Example could be water for solvent and sodium chloride, that is table salt. Okay, table salt. If we add sodium chloride salt in water, then we'll get what we'll get? We'll get a solution of salt water. So that is called a homogeneous solution. It will be completely miscible in that. Components of a binary solution. It includes a solute and a solvent, and if both the it, that both the solute and solvent could be solid in solid state, then that solution will be called as a solid solution. If both the component if when the solvent is in solid state, is called a solid solution. When the solvent is in liquid state, is called a liquid solution. And when the solvent is in gaseous state, it is called a gaseous solution. Okay, so we'll see different combinations of different states of the solvent and the solute and their example. For example, if we have a solid solute and solid solvent, then the form solution is a solid only, and the examples could be alloys or stones. Stones, the ores that we get, it contains a mixture of different metals, and similarly in the case of alloys, we make that also is a combination of defined combination of different metals. Solid, if the solute is solid and the solvent is liquid, then we'll form a solution, like if we are adding salt or sugar in water. Sugar and salt are solid and water is liquid. So it is an example of that. Example for solid, solute, and gaseous solvent are iodine vapors. Iodine vapors are basically purple in color. Then iodine is basically small little balls are there, but when you leave it in the air, it get evaporated. It get sublimation, sublimates in air, and brownish, purplish. We can say vapors are released. Then that is called as a solid solute in gaseous solvent. Example of liquid solute in solid solvent are mercury in metal amalgams. So basically mercury is in liquid state, and solid amalgam. Amalgam is a material. Amalgam is a basically combination of uh, some salts, and it forms a hard mass. When both of them combine, it form a hard mass, and that is called an amalgam. Example of liquid and liquid solute and liquid solvent contains alcohol in water. Both liquid solute Here CH3OH, that is or liquid, we have water. So that is an example of alcohol in water. Solute, and if we have a solute as liquid and solvent as gas, then that will be example of that will be moist air. Air is basically gaseous gas. In that, if water droplets are present, then that will form a solution of liquid solute and gaseous solvent. Example of gas solute and solid solvent are oculated hydrogen on platinum and nickel. Basically, these three metals have a tendency to absorb absorb gases. Generally, they are used for catalysis reaction, where the hydrogenation kinds of reaction they are used, and on that they absorb hydrogen gas. So basically, the absorbed material, platinum with absorbed hydrogen, that material could be considered as a solution of a gaseous solute, that is hydrogen, and a solvent, solid solvent, that is a metal. Example of gas solute and liquid solvent could be aerated water. So basically, when we use soda, in soda you see the bubbles, in bubbles are there, so CO2 bubbles are there. In that, basically liquid is the solvent and gas is the solute added. Solute is gas, that is CO2. Example of solution of gas, and gas is air. Air is a combination of nitrogen, oxygen, helium, etc. So air is an example of that. Coming to the concentration terms and how we are defining concentration. So we till now we saw that combination of solute and solvent. So how will we define that how much amount of solute is added? Yeah, a solution is basically a binary solution. For simplicity, we say it is a combination of solute plus solvent. Let's say there is a sample A in this beaker, sample A, and this one is sample B. So here you have added 5 gram of NaCl in 1 liter of water. Okay, and in this one you have added 10 gram of NaCl plus 1 liter of water. Both of them are miscible solutions. So their color is same. Okay, how will you differentiate? Okay, here let's say 10 molecules, 10 grams of NaCl is present in water, and here only 5 grams are present. So how will you differentiate these? To differentiate these situations and to judge or to quantify, basically to quantify that how much of a solute is present in a solution. Okay, how much is solute is added to a solution, we need to define the term called concentration. Okay, concentration is a term that quantifies or that defines the whole amount of solute added to a solvent. It defines the composition of a solution. Okay, so we'll understand that. So concentration, it is the amount of solute in a given amount of solution, as I said. So there are different terms to define concentration. First one you understand, that is mass by volume percentage. You can say it could be defined as mass of solute dissolved in 100 ml of solution. It is basically W by M percent, where you are saying that it is mass of solute dissolved in 100 ml of solution. Example, let's say uh, mass of solute, but we consider, let's say, NaOH. NaOH, I am taking 40 grams of NaOH and I am dissolving it in 200 gram of, okay, 200 gram of solution, 200 ml of solution basically. Okay, well, it is a liquid, no, 200 ml of solution. So what is the weight by volume percentage? Weight by volume of the solution into 100, that is defined as W by V into percentage. Cut these numbers, so it will come out to be 20%. Okay, I hope you understood. Similarly, another term is molality. Molality is the term that is defined as it is the number of moles of solute present in 1 kg of solvent. So first you need to understand what are moles. Moles are defined as a weight of solute by molecular weight. Molecular weight. So let's say first tell me if I have 80 gram of NaOH, what are the number of moles? Calculate number of moles. Number of moles is defined at weight of solute, that is 80 gram. Okay, divided by molecular weight. What is the molecular weight of NaOH? Molecular weight of NaOH could be, it is sodium has a weight of 23 plus oxygen has a weight of 16, hydrogen has a weight of 1. So 23 plus 16 plus 1, it comes out to be 40 gram per mole. Molecular weight is defined as the weight of 1 mole of a compound. So 40 gram per mole. Please pay attention to the units. So if I divide 40 by 80, it is 2. Gram is cancelled by gram. So the mole is in division over here. So it comes out to be 2 mole. Got it? This is how you calculate the number of moles. So since we are discussing molality, molality is the number of moles of solute, number of moles of solute divided by mass of solvent in kg. Pay attention, here it is written as mass of solvent only, and that too in kg, not liters. It is not asking for volume, it is asking for mass. So let's give you an example. Let's say I have 120 gram of NaOH in how much? 400 gram of H2O. Okay, calculate the molality. Calculate the molality. I'll give you like 1 minute. Please calculate the molality for this. I hope you guys are doing it. So first we need to calculate molality. Molality is, what is the formula? Molality formula is number of moles of solute by volume of solution in liters by mass of solvent in kg. Mass of solvent in kg. But are the number of moles for NaOH? Number of moles, as I have defined, it is defined as a weight of solute divided by molecular weight, and by that is further divided by This is the formula for number of moles. Mass of solvent in kg. So weight of solute, what we have weight of solute over here? 120 gram of NaOH. Molecular weight of NaOH, that is 23 for sodium, 16 for oxygen, and 1 for hydrogen. So this is gram per mole. Okay, this was gram divided by mass of solvent. Solvent is over here is H2O. Mass of solvent is 400. We need the mass in kg. So gram will be divided by 1000 and it will become mass in kg. So we can say 120 divided by 40 are the number of moles, divided by 400, that in kg gives. So these are gram over here will cancel out. So the value will come out 120 by 40. It will give you 3. 3 by 400 into 1000. The units will be mole per kg. The value will cut over here. So it will give you 30 over 4. That is 15 by 2. That is 7.5 mole per kg. You can say. Okay. The answer is 7.5 mole per kg. Coming to the next one, that is molarity. Molarity is defined as the number of moles of solute present in 1 liter of solution. Here pay attention, molarity and molality. What is the difference? Number of moles of solute, number of moles of solute. Here in the division it is mass of solvent in kilogram, and over here it is volume of solution in liter. So for the same question, if I say 120 gram of NaOH in, let's say I'll say 200 gram or 200 ml. In this case, since the value is written in liters, it is required as the volume of the solution. Pay attention over here, it is the solution and that too in volume. Volume of the solution is required. So 200 ml of solution. Calculate the molarity. Molarity will be, it is defined with capital M. So molarity will be number of moles of solute. Moles of solute is weight by molecular weight. 40 is the molecular weight. Moles divided by volume of solution in liter. 200 ml is the volume of solution. We need it in liter, so we'll divide by 1000. So the value will come out 120 by 40 into 200, and it will go like that. So 315 moles per liter, or you can say 15 capital M. You can write moles per liter as capital M. It is defined as molarity. Okay. I hope you guys are getting what I am trying to explain. I give you some questions to practice as well. Third term that we discuss here is the normality. Normality is defined as the number of gram equivalents of the solute dissolved per liter of the solution. So, what is the difference between molarity and normality? Pay attention, please. Molarity was defined as the number of moles of solute. Here the normality, it is defined as number of gram equivalents of solute. So what is the difference? Number of gram equivalents, that is gram equivalents. Okay. Number of gram equivalents, it is defined as moles by equivalent weight. Weight of the solute, weight of solute by equivalent weight. and equivalent weight is divided by molecular weight divided by n factor. So weight of solute. Weight of solute by molecular weight is defined as moles, we can say. So number of gram equivalent is equal to moles into n factor. We'll solve some questions regarding this in further slides. So please pay attention to the relations over here. Now we can say that molarity and normality are interrelated, and so we can say normality is equal to number of gram equivalents we defined as the moles into n factor. I'll explain what is n factor divided by volume of solution in liter. In liter. And if you consider this part, moles of solute by divided by volume of solution in liter, you will understand that normality is equal to molarity. This is the formula for molarity. Molarity into n factor. Okay. So we'll do some questions. Please pay attention to all these concentration terms. First one is molarity. Molarity is defined as the number of moles of solute by per liter of a solution. Please remember these formula and note down these formula. I'll give you some questions. You need to practice these questions. So molarity is defined as mass of moles of solute by volume of solution in liter. Molality is defined by number of moles of solute per kilogram of solvent. Formula is moles of solute by weight of solvent in kg. Normality is defined as gram equivalents of solute by volume of solution in liters, and we also discussed that how it is related to molarity. Normality is equal to molarity into n factor. Okay. Formality is a new term. Formality is the number of gram formula masses of the ionic solute dissolved per liter of solution. So basically it is for ionic solutes. Ionic solutes, and the formula used over here is weight in gram by formula weight into divided by volume of solution in liter. Mole fraction. Mole fraction is equal to the moles of one component divided by the total moles of the solution. We'll also discuss some questions regarding this. We'll practice some question regarding this. And the last term is parts per million. Parts per million is the value that represents the part of whole number in the units of 10 raised to power minus 6. Okay. So we'll also discuss this 10 raised to power plus 6. Sorry. So coming to the first question, that is calculate the molarity of the sugar solution if 4 liter of the solution contains 8 moles of sugar. Please do this question by yourself. I'll do it after 1 minute. Do it by yourself and then match your answers with mine. So, I hope you guys are doing. So, let me also solve molarity. Molarity is defined as number of moles of solute by volume of solution in liters. Okay. So Number of moles of solute. Here moles of solute. What is the solute? Moles of sugar. Sugar is the solute here. So sugar number of moles given, 8 moles are given. Okay. See over here in the question 8 moles are given. Volume of solution. What is the volume of solution for this? 4 liter. They have mentioned over here 4 liter. So molarity that is represented by capital M is equal to number of moles of solute, that is 8 by volume of solution in liter. 8 moles by volume 4 liter. It will give you 2 moles per liter, or you can say 2 molar. So the answer will be 2 molar. Match your answer with mine. Let's move to the second question. What is the molarity of the solution containing 5 moles of solute in 250 milliliter of solution? Please solve this question. I'll give you 1 minute. I hope you guys have solved. So let me start. Molarity. Molarity is defined as number of moles of solute by volume of solution in liters. So number of moles of solute. What are the moles in this question? Moles are 5 moles. Solute moles are 5. Volume of solution in liter we require. Volume of solution, what they have mentioned is 250 ml. But we require in liter. So what we'll do? 250 divided by 1000. That will give us the value in liters. That is, this is the value in liter. 0.250. Okay, liter. So let us put the values. 5 moles of solute divided by 250 by 1000 volume in liter. Rearrange and solve the equation. 250 into 1000, that will give you 4. So the value is 20 molar or 20 moles per liter. Okay, answer is 20 moles per liter. Check your answers with mine. Let us move to the next question. So the next question is, how many moles of NaOH are needed? How many moles of NaOH are needed to dissolve in water to make 4 liters of 2 molar solution? Please solve this question. I'll give you 1 minute. I hope you guys have solved. So, molarity. Since they have mentioned 2 molar of solution, so first you write the formula of molarity. Molarity is number of moles of solute by volume of solution in liters. Put the values given. So they have given that the solution has a molarity they have mentioned it is 2 molar. Number of moles of solute. You need to calculate. This is unknown. Number of moles of solute. It is not known. You need to calculate this value. Volume of solution they have mentioned. What is the volume of solution? Volume of solution is 4 liter. So number of moles will be solute will be multiply this by with that is 2 moles per liter. We can write molar as moles per liter into 4 liter. That is 2 moles per liter means it is in it is below. So 4 liter. Liter cancel. It will give you 8 moles. Check your answer with mine. The answer is C. 8 moles. Let us move to the next question. The question is how many moles of sodium are present in and are needed to make 4.5 liters of 1.5 molar sodium solution. Please calculate the value of number of moles. I'll give you 1 minute. I hope you guys have calculated already. So let me solve molarity. Again, they have mentioned 1.5 molar sodium solution. Molarity is number of moles of solute by volume of solution in liters. So number of moles are asking us to calculate. Number of moles we need to calculate. Unknown value. Molarity they have mentioned. What is the molarity? 1.5 molar. Volume of solution they have mentioned 4.5 liter of solution. 4.5 liters. Again, number of moles will be 1.5 molar into 4.5 liter. You can write molar as 1.5 moles per liter and into 4.5 liter. This liter and this liter will cancel out and you will get 1.5 into 4.5. Calculate this value. What is the value of 1.5 into 4.5? It will come out to be nearly 6.75 moles. Okay. Here we have moles left out. So the unit is moles. Number of moles calculated to be 6.75. So the answer is A. Calculate check your answer with mine and please pay attention to the units. Moving to the next question. Now we are moving to the questions for molality. Molality. So, what is the question? Calculate the molality of solution prepared from 20 grams of NaOH in 5 kg of water. So, I'll give you 1 minute to calculate this. Please solve it. In this question, they have asked us to calculate the molality. So first, please write the formula of molality. Molality represented by capital small m. Molality is defined as number of moles of solute by volume of by mass of solvent in kg. Sorry, here you take mass of solvent only, not solution. Solvent, that too in kg. So, what are the values given? They have given that NaOH is 20.20 grams. Okay, water has a mass of 5 kg. So first you need to calculate the number of moles of NaOH. NaOH is the solute over here. No, this is the solute. So NaOH moles is molecule mass weight of the solute by molecular weight. Molecular. So weight of the solute, what is the weight of solute they have given? They have given 20.20 gram. Molecular weight of NaOH is sodium has a 23, oxygen has a 16 and hydrogen has a 1 gram per mole. Okay. So gram and gram will cancel out and will be left with 20.20 divided by 40 mole. I hope I am clear up to here. So number of moles of NaOH that we have calculated are this 20.20 divided by 40 mole. It will come out to be nearly, let's approximately, let's say it is taking as it as 20 and divided by 40, we'll get the value 1 by 2, that is 0.5 mole. Okay, coming to the formula, that is molarity, that is number of moles of solute. Moles of solute we have calculated as 0.5 moles. The mass of solvent they have mentioned here, solvent is water. So mass of solvent is 5 kg. They have mentioned that molarity is the number of moles of solute divided by volume of solvent in kg. We need not to change the units because the unit is kg only. So 0.5 divided by 5, what will be the value? Moles per kg. It will give you 0.51 mole per kg. Okay, or you can say 0.1 small m. That is saying that it is 0.1 molar. Check your answer with mine. Let us move to the next question. Please read the question carefully. A 6 gram sugar cube uh, is dissolved in 300 ml juice of at 5 degrees Celsius, what is the molality of the juice? Given the density of water at 5 degrees Celsius is 0.975 gram per ml. Here you need to pay attention to the density formula. Density is equal to defined as density is mass by volume. Pay attention to this and calculate the molality by yourself. I'll solve it in 1 minute. Okay, I'll give it 2 minutes for this one. So please calculate the value and then match yours with mine. I hope you guys have solved the equation. So let me start. We need to calculate molality. Molality is defined as number of moles of solute. In this case, solute is sugar. Solute is sugar. Okay. And what is the mass of solvent in kg? What is the solvent over here? It is juice. Okay. So first calculate the number of moles of sugar. Number of moles can be defined as weight of sugar given sugar divided by molecular weight. Here they have given you the formula for sugar, that is C12H22O11. So weight of the sugar, what weight they have provided? They have provided 6 gram of sugar they have taken. Molecular weight will be, calculate the molecular weight, 12. Carbon has a molecular weight of 12. So 12 into 12 plus 22 hydrogen molecules are present, hydrogen atoms are present, that has a molecular weight of 1, plus 11 atoms of oxygen that each has a molecular weight of 16. So calculate this value. It will come out to be 342 gram per mole, since it is molecular weight, that is gram per mole. So 342 gram per mole. Gram and gram will cancel out. So the number of moles is 6 over 342 mole. I hope you are getting getting this. So if you divide it by this, then the value will come out to be 0.0175 mole. So till now we have calculated the number of moles. Other thing that we require is mass of solvent in kg. So mass, they have provided what they have provided. They have provided density. Density is equal to mass by volume. Okay. They have provided volume of the solvent, that is 300 ml, and we need to calculate mass. Density they have provided as, what is the density they have provided? They have provided at 5 degrees Celsius the density. So they have provided the density at 5 degrees Celsius. Density at 5 degrees Celsius is 0.975 gram per ml. So what will be the mass? Mass is equal to volume into density. Volume they have provided 300 ml. Density they have given 0.975 gram per ml. Please pay attention to the unit. This ml and this ml will cancel out and will get multiplied 300 with 0.975. So the value will come out to be 292.5 grams. Okay, ml got cancelled. So this is the mass of solvent in grams. But we require the grams mass of solvent in kg. So how we are going to convert that? We will divide this mass by 1000. So then we'll get the value in kg. Okay. Uh, so this is the value in kg. Put these values in the formula. Molarity is equal to number of moles of solute. How many moles you calculated? It is 0.0175 mole. What is the volume? Volume is 0.2925 kg. We divided this volume by 1000, no? So this is the by calculating this value, it will approximately comes out to be 0.59 moles per kg, or you can say 0.59 molem. This is the molarity. Please check your answer with mine. The answer is 0.59 molal. It is molal, not molar. It is the molality. Pay attention to this particular question. Here we have used a density formula to calculate the mass of the solvent. Let us move to the next question. Before that, let me again explain you what is the relation between molarity and normality. Molarity we defined as capital M, that is number of moles of solute by volume of solution in liter. Okay. Normality, on the other hand, it is number of gram equivalents of solute divided by volume of solution in liter. So, what is this number of gram equivalents? Number of gram equivalents is equal to molecular weight. It is equal to weight of solute. Sorry, weight of solute divided by equivalent weight. Now, what is equivalent weight? Equivalent uh, equivalent weight is equal to molecular weight by n factor. By n factor. So compiling all these formulas into one, what will you get? Normality is equal to number of gram equivalents. Number of gram equivalents is the weight of solute. I'll write weight of solute divide by equivalent weight. What is the formula for equivalent weight? Equivalent weight is molecular weight divided by n factor. So n factor divided by n factor. Okay? That is multiplied by volume of solution in liter. So if you take this n factor in the numerator, then you will get normality is equal to weight of solute by molecular weight into n factor divided by volume of solution in liter. So if you pay attention over here, if I consider this part of this formula, weight of solute by molecular weight into volume of solution in liter, this part gives you number of moles. Number of moles, volume of solution in liter into n factor we have. This part is giving you what it is. Isn't it familiar? It is giving you molarity. Molarity. Please pay attention to the above formula. Number of moles of solute by volume of solution in liter. Isn't it the same? So normality is equal to molarity into n factor. Got it? So this is how both the things are related. Coming to the n factor. So let me explain this with this example. N factor. Here you can see this arsenic acid is reacting with sodium hydroxide and forming this sodium hydrogen arsenate with two molecules of H2O. So here you saw that 2H plus from this arsenic acid and 2OH minus reacted to give 2H2O. Okay, only 2H plus reacted. So basically N factor is defined as number of H plus or number of OH minus released, or you can say number of electrons transferred. In other terms you can also say, so in number of electron transfer you can say there 2H plus has released and the whole process is 2 electron transfer step. 2 electrons are being taken or released. So number of H plus released over here by the acid is 2. 2 H plus ions are released. So N factor for this arsenic acid is 2. For example, if I tell you, let us say oxalic acid. Oxalic acid, COH, COH. It gives you oxalate, COO minus, COO minus, and 2H plus. So what is the N factor for oxalic acid? It is 2. 2H plus has released, no? That's why the value is 2. If you have sodium hydroxide, what is the value of N factor for this? Only one OH minus will be released. So that will give you N factor of 1. Okay. So I hope you guys understood. There is a lot to understand regarding this N factor thing. So I'll make a separate video for that. For now, let us just understand the N factor is defined, could be defined as the number of H plus or OH minus release. So in this reaction, total number of H plus release are 2H plus for the acid. So normality, it is basically H3P is there. Okay. So normality is defined as molarity into N factor. Molarity they have mentioned for phosphoric acid is 1 molar. N factor for this phosphoric acid is 2. So normality will be 2 normal. Okay. That is so simple to understand. Please calculate the value for this one. I'll give you 1 minute. Use the same formula. Normality is equal to molarity into N factor. Normality for the first question. Here you can see for NaOH, for 1 mole of NaOH, how many OH minus will be released? Only one OH minus mole of OH minus will be released. That means the N factor over here is 1. So normality is equal to molarity into N factor. So molarity is 0.1381. N factor is for 1 mole of NaOH. How many OH kinase are released? Since it is 1, so the value is 1. N factor normality will become out to be 0.1381 normal. It is similar to molarity since the n value is n factor value is equal to 1. Similarly, for the second example, H3PO4, H3PO4. Uh, I hope you guys know the structure for H3PO4. It is POOH, OH, and OH. So it will release 3 H plus ions. 1 mole of phosphoric acid will release 3 H plus ions. So the N factor value will be 3. Normality is defined as molarity into N factor. So we can say 0.5 to 0.0521 into 3 will give us 0.56 normal. Let us move to the next question. Now we'll talk about the mole fraction. Mole fraction, let me uh, tell you again what is the mole fraction. Mole fraction is defined as mole fraction. It is defined as the fraction of different moles, different components of the component of a solution. So mole fraction, let us say we have a solution containing A component and B component. In this solution, there are n moles of A and n moles of B. So, what is the mole fraction? Mole fraction is defined by this term. It is something like this. So, a kind of X. So, mole fraction for A component. It is defined as moles of A divided by total number of total number of moles of all components. Okay, so the mole fraction for A is Na. How many components we have? We have two components. So divide by number of moles of A, divide by number of moles of B. This is the mole fraction of A. Similarly, if they are asking you to calculate the mole fraction for B, it is defined as moles of B divided by number of total moles of component of all components. So mole mole fraction for the component B is equal to number of moles of B divided by number of moles of A plus number of moles of B. So this is how you calculate the mole fraction of components present in a solution. And also, please note that mole fraction of all the components give you a value of 1. Mole fraction of A plus mole fraction of B will give you a value of 1. So let me also define this, make it clear to you. Let's say we have three components. A, we have three components in a solution A, B, and C. Okay, it is forming a solution. Moles of A are Na, moles of B are Nb, moles of C are Nc. Calculate the mole fraction of A. Mole fraction of A will be moles of A divided by moles of all the components. That is Na plus Nb plus Nc. For the mole fraction of component B, it will give you number of moles of B divided by number of moles of all the component, that is Na plus Nb plus Nc. Mole fraction for component C can be defined as moles of component C divided by moles of component of all the component, that is Na, Nb, and Nc. If you add up all the mole fraction of A, mole fraction of B, mole fraction of C, it will give you the value 1. How? Let me tell you. So put the values of moles of put the value over here. Mole fraction of A, what we calculated over here, it is Na divided by Nb plus Nb plus Nc for mole fraction of A. Similarly, for mole fraction of B, it is Nb divided by Na plus Nb plus Nc plus mole fraction of number of moles of C divided by Na plus Nb plus Nc. So if you are going to add up all this, since the denominator is common, Na plus Nb plus Nc. So when you will solve the equation, it will come out to be Na, Nb, Nc. So what will be the value? Na plus Nb plus Nc divided by Na plus Nb plus Nc. What is the value? They both will cancel out and will give you the value 1. That's how we'll get the while adding the mole fraction of all the components, the value will come out to be 1. So I hope you guys understood how we calculate the mole fractions. Let us solve for this question. Calculate the mole fraction of NaCl and H2O if 0.010 moles of NaCl are dissolved in 100 grams of pure water. So, mole fraction for NaCl. Okay. So, first you need to calculate the number of moles for NaCl. Number of moles of NaCl divided by number of moles of NaCl plus number of moles of H2O. To calculate, since it is a two component system, NaCl plus H2O forming a solution. So, to calculate the mole fraction for NaCl, you need to provide the number of moles for NaCl divided by total number of moles of NaCl plus number of moles of H2O. So, what are the number of moles of H2O? Number of moles of H2O could be defined as weight of H2O divided by molecular weight. What is the weight of H2O they have provided? They have provided 100 gram. So 100 gram molecular weight of H2O is hydrogen has 2 hydrogens are present, 18 16 for oxygen. So it will give you 100 divided by 18. This is the moles for H2O. Putting these values over here, number of moles of NaCl they have already provided 0.010. Number of moles of NaCl again 0.010. Number of moles of H2O we have calculated. 100 divided by 18 will give you 5.56. The value will be close to 5.56. So putting the value over here 5.56, 0.010 when you divide it by 5.66, the sum will give you 5.66. So the mole fraction will come out to be 0.018. Similarly, calculate the mole fraction of H2O. Mole fraction for H2O will be number of moles of H2O divided by number of moles of NaCl plus number of moles of H2O. 5.56 divided by 0.010 plus 0. Plus 5.56. So the value will come out to be 0.982. I hope you guys understood. Please pay attention to the calculations and the formula used. Let us move to the next question. I want you guys to solve this question first, then I'll solve. So calculate the mole fraction of acetone in a solution containing 1 mole of benzene, 2 mole of carbon tetrachloride, and 7 moles of acetone. Here we have three component solution. One is benzene, other one is carbon tetrachloride CCl4, other one is acetone. So they have asked you that number of moles of benzene, carbon tetrachloride, and acetone they have provided. So number of moles of benzene they have provided to be 1. Okay, the value is 1. Number of carbon tetrachloride moles they have provided as 2. Number of acetone moles they have provided as 7. So mole fraction for acetone will be number of moles of acetone divided by total number of moles of all the component. Here number of moles of acetone they have provided as 7. Number of moles of all the component. So for benzene it is 1, for carbon tetrachloride it is 2, and for acetone is 7. 7 divided by 10, it is value 0.7 mole fraction. Mole fraction of acetone is 0.7. Mole fraction has no units because moles and moles get cancelled out. Here in the numerator you have moles, in the denominator you have moles. So the moles and moles will cancel out and you will be having a unitless value. That is mole fraction of acetone is 0.7. I hope you guys are getting what I'm trying to explain. So let us move to the next question. 25.7 gram of formaldehyde is dissolved uh, of formaldehyde dissolved in 3.25 moles of carbon tetrachloride. Calculate the mole fraction of formaldehyde. Here we have a binary solution. We have two components, formaldehyde CH2O plus carbon tetrachloride forming a solution. They are asking you to calculate the mole fraction of formaldehyde. So solve this question. I'll do it in 1 minute. So let's start. So mole fraction of formaldehyde will be number of moles of formaldehyde divided by number of moles of all the component. Here how many components are present? Number of moles of all components. We have two components. So we have number of moles of formaldehyde CH2O divided by number of moles of formaldehyde. That is one component, and another component is carbon tetrachloride. So they have saying you need to first calculate the number of moles of formaldehyde. Number of moles of formaldehyde or CH2O. Excuse me. That is weight by molecular weight. What is the weight for formaldehyde they have given? They have given 25.7 gram. Molecular weight for formaldehyde CH2O. Carbon has a weight of 12. Hydrogen has a weight of 1. 1 into 2. 2 atoms are present. 16 for oxygen. So 12 plus 2 plus 16. That is 30. Okay. 30 gram per mole. So if you divide 25.7 divided by 30, you will get a value of 0.856 moles. Okay. So solving the mole fraction now. Mole fraction is defined as number of moles of formaldehyde that we have calculated to be 0.856. See, we calculated this value to be 0.856. So, number of moles of formaldehyde divided by number of moles of formaldehyde plus number of moles of carbon tetrachloride. They have mentioned it to be 3.25. This is the formula that I am using. Number of moles of formaldehyde divided by number of moles of all the components. That is formaldehyde plus carbon tetrachloride. So the addition will give you 0.856 divided by 0.856 plus 3.25 will give you 4.106. 4.106. So the value will come out to be 0.208. Okay, this is the mole fraction for the formaldehyde. I hope you guys understood. Let us move to the next question. The solution is prepared by mixing 25 gram of ethanol, 25 gram of water. Determine the mole fraction of each component. That means you have need to calculate the mole fraction of water and ethanol and water. So here it is the binary solution again. CH3, CH2OH. You have ethanol plus water. Two components you have. 25 gram of this is provided. 25 gram of water is provided. You need to calculate the moles of this. So moles is defined as molar weight given divided by molecular weight. What is the molecular weight? We have two carbons plus 3, 2, 5 and 6 hydrogens plus 1 oxygen. So 25 divided by 24 plus 6 plus 16, it will give you 46.25 divided by 46.07. So the number of moles of ethanol CH3 CH2OH will come out to be 0.543. Okay. Similarly, moles of water, that is 25 gram, divided by molecular weight of water, 16 plus 2 into 1. 16 for oxygen and 2 for hydrogen. Two hydrogens are present and 1 is the weight. So 25 by 18. It will give you 1.34 moles. So number of moles of H2O you have this. So number mole fraction of CH3 CH2OH, that is moles of CH3 CH2OH divided by moles of CH3 CH2OH plus moles of water. So the value will come out to be 0.543 divided by 0.543 plus 1.34. So mole fraction will become out to be 0.29 for ethanol. Similarly, mole fraction for water. Moles of water divided by moles of water plus moles of ethanol. Moles of water we have 1.34. Moles of water we have 1.34 plus moles of ethanol 0.543. The value will come out to be 1.34 divided by 1.886. It will give you 0.71. 0.7. I hope you guys understood. We'll move please check your answer. Here we have calculated the mole fraction and we'll move to the next part of the video with the topic solubility. For the chapter 2 of NCERT, that is solution. Thanks for watching. That's all for today. Please practice more questions for these concentration terms. That is molarity, mole fraction, normality. Okay, these questions are really important because they will be used in further in chemistry and they are going to be used everywhere. So please do remember their formulas and try to practice as much as question possible. Bye. Thank you.